Okay, here's a little extra video. I've been getting a lot of questions and noticing a lot of confusion between cofunctions and reciprocals. Now, cofunctions are, we have our sine, cosine, tan, cotan, secant, cosecant. If you notice, half of them, you just put the word or the letters co in front of it and you get the other. So sine of an angle, and if we put co in front of it, we get the cosine function. And tangent, we got the tangent of some angle, and if we put co in front of it, we get the cotangent function. And last we have secant of some angle and the cosecant of some angle. Now these are the cofunctions. They're paired up just by adding or subtracting the co from in front. And the thing about these is, if I put some angles in these parentheses, what we're going to be performing this trig operation on, if I happen to put complementary angles in here, and remember complements add up to 90 degrees, so I could put a 10 in with the sine and an 80 with the cos. Or I could put a 20 with the sine and a 70 with the cos. Or a 30 and a 60. They add up to 90. As long as I put complementary angles in these cofunctions, the value that they will put out are equal. And that applies to all the other pairs of cofunctions. Down here I could put in tangent of 1 is equal to the cotangent of 89. As long as those angles are complements, the values will be equal. And again, the same with cosecant and secant. I could even do the secant of 0 and the cosecant of 90 are going to be exactly equal. Or, 45 and 45 degrees. The cofunctions of complements have equal values. And over here on the other one, we have reciprocals. And a lot of people know reciprocals. Maybe you heard in middle school somebody say reflipricals. So that just means if we take one and flip it over, we get the other. And we notice these don't follow the co-function pattern. And when I was in school, I always just memorized them in this sort of pattern, a 3x2 block. Sine, cosine, tangent, and then go down to cotangent and go back to the left, secant, cosecant. So you're going sort of clockwise, and you lay them out in a 3x2 pattern. And this way, the reciprocals line right up over top of each other. Sine and cosecant are reciprocals. If I have sine, I turn it upside down and get cosecant. Like say I knew the sine of some angle was 1/3. Well, the cosecant of that same angle theta is going to be 3/1 or just 3. Same here with cosine and secant. They are reciprocal identities. And here we have tan and cotan. Tan and cotan are cofunctions, and they also happen to be the reciprocals of each other. And we did some examples in class, and you got some homework. I can't remember if some of these were part of the homework, but let's just check them out. We're giving two things. We have the sine of 30 is a half, and we know the tan of 30 is this square root of 3/3. Just based on this information and the identities and the stuff we have up here above, we can figure out the missing A, B, C, and D. So let's see here. The first thing they ask for is the cosecant of the same angle 30. Both of these are 30 degrees. They're asking for the cosecant, and we have sine, and we should remember, okay, sine and cosecant are reciprocals. If I have sine, I turn it upside down and get cosecant. So I know if sine is 1/2, cosecant is 2/1 or just 2. No computation involved. I didn't have to square anything or divide or do anything fancy. I just had to recognize that these had the same angle. They are reciprocal identities. So I just flipped over the value of sine of 30 and I got the cosecant of 30. So now B is cotan 60. And here I again notice my given angles are both 30-degree angles. This is 60. 30 and 60 are complements. That should send off a little light bulb over your head. Say, okay, I know the cotan of 60, or I'm trying to find the cotan of 60. Well, if I drop the co off and look at the complement of this, that would be this is cotan, so the tan of 30. Do I have the tan of 30? Sure, it's right here. And these cofunctions of complements are equal up here. That tells us that these are equal. Tan of 30 and its co of its complement, this is also going to be equal to the square root of 3/3. Come down here to letter C, the cosine of 30. Well, let's see here. Cosine is 1 over secant. We don't have secant. Cosine. Oh, for this one, we are going to have to go to, it looks like a Pythagorean identity. The sine squared of an angle plus the cosine squared of the same angle are equal to 1. And we were given sine. So we have sine is 1/2, so that's 1/2 squared plus cos squared equals 1. And 1 squared is 1/4. And I'm going to subtract that from both sides. I'm going to subtract 1/4 from here and the right side. Oops, that's 1/4. So here we now know the cosine squared of this angle is 1 minus 1/4 is 3/4. And since I have cosine squared, I want a square root. So the square and the square root cancel. The cos of the angle is going to be, I have to square root the right side, square root the numerator, and it's square root of 3. And if I square root that denominator 4, the square root of 4 is 2. So I'll have the cosine of this 30-degree angle is the square root of 3 over 2. The last one here is the cotan of 30. Now let's look up here. Cotan is 1 over tangent. Do we have the tangent? Yeah. Tan and cotan of the same angle, tan of 30, the cotan of 30, are reciprocals. So if the tan of 30 is root 3 over 3, I turn it upside down. 3 over the square root of 3. And don't forget, leaving radicals in the denominator is bad math manners. So we rationalize by multiplying by the root 3 over root 3. And we will get in our numerator 3 square roots of 3. And root 3 times root 3 is the square root of 9. And the square root of 9 is 3. And then you might notice that these are going to cancel. So we're just left with simply the square root of 3. So the cotan of 30 is the square root of 3.